So what is an LLM? A large language model. What is it? How is it different from generative AI? How does it differ from a frontier model? How does it differ from like AI in general? How does it differ from machine learning? I will explain these things in super simple, non-technical terms, because that's what I do for a living. I'm a technology journalist, and I explain complicated concepts in simple ways. And I started out as a computer programmer. My degree's in mathematics. And so I understand that I'm simplifying things, and that when you simplify things, they are no longer technically correct. So if you want to complain about the technical correctness of my explanation, please do so. Please do so in the comments. I welcome it. I would appreciate it very much. Okay, so let's get into it. I've been covering artificial intelligence for years. I've been a technology journalist for 20 years, and I've seen the definitions come and go. And first of all, I'm going to say that my definition of AI, machine learning, LLMs, generative AI, is how people are using it, not the correct, proper definition. I'm a descriptivist when it comes to language. Language is how people use it. Language is not how it's written in a dictionary. Language is not, well, technically it's this. Language is what people use it for. So how are people using the term LLM? A large language model is an AI model that's built on language. So this is chatbots. This is a type of generative AI. And there's like overlapping circles of all this stuff. So let's first talk about the difference between an LLM and generative AI. Generative AI is any type of artificial intelligence which generates new content from scratch. And generative AI does, in fact, generate new content that has not been seen before. It is not cutting and pasting from old content and creating new content. The way that generative AI works is it gets a bunch of training data. It looks at the patterns between the training data. This word usually comes after this word. This is what people mean when they say autocomplete on steroids. This word usually comes after this word. But then generative AI looks at the patterns behind the patterns. And then it looks at the patterns behind the patterns behind the patterns. And then the patterns behind the patterns behind the patterns behind the patterns. And layers of patterns, you start to get to something that looks a lot like intelligence. It quacks like a duck, it walks like a duck, it feels like a duck. And if you want to see it do any kind of original analysis, just give it something unknown to analyze. Give it an essay or short story you've written. I've uploaded entire books just to see what it thought about them. And you can turn it so it doesn't use it for training data if you don't want your stuff to go anywhere. And ask it original questions like, what's the biggest plot hole in my book? It will find the biggest plot hole, even though nobody has analyzed this book before. It's nowhere on the internet. It is doing original analysis. Or you can ask generative AI for a picture of a cat drinking coffee on the moon while playing a ukulele. This picture has never been seen before. It creates an original picture based on the patterns that it has observed of a cat, of a ukulele, of this, of that, of the other thing. It does not cut and paste the original picture. If you ask it for the Mona Lisa, it has seen a lot of the examples of the Mona Lisa, so it knows the patterns of the image that go into making a Mona Lisa. But the final image it produces will not be identical to the Mona Lisa. It will be a newly generated version of what it learned about the Mona Lisa. So that's where the generative AI part comes from. And there's a variety of ways that generative AI generates stuff. In a large language model, it does a next word prediction, or technically next token prediction. In an image model, you start out with random pixels on on an image, and then it slowly looks for patterns in those pixels that approximate a cat playing a ukulele, what it thinks a cat playing a ukulele would look like. So there's different ways to generate stuff. So a large language model is a type of generative AI that is based on language, as opposed to images, video, audio, 3D models, computer code. So all different kinds of generative AI are out there, and a large language model just focuses on the language. They typically know a lot of languages. And there's a new kind of generative AI coming out, a multimodal AI that is trained on all different types of training data all together. So it's trained on videos and images and audio and text. And then there's multimodal AIs that are separate AIs. There's a large language model and an image model and a video model, and they can talk to each other, but they're separate models trained separately. So you can get like a model that says you want something that looks like this. It will generate a text prompt, then it will send the text prompt to an image model. So that's the older version of multimodal models. These days, we're getting closer to a world model where it's natively multimodal. It natively understands all different kinds of input, which makes it smarter and gives it a better understanding of how the world works. There are also reasoning models, and they're a type of large language model where the model gets more time to think. So before putting out the first token, it sits there and thinks about all the different implications and comes up with possibilities and picks between them and does the pros and cons, and then finally decides what it's going to produce. That's a thinking or a reasoning model, and we're getting a whole bunch of those coming out right now. Frontier model. So what's the difference between a large language model and a frontier model? So a frontier model is whatever model of its category is at the cutting edge. So OpenAI has a frontier model, the latest version of the ChatGPT. Anthropic has a frontier model, the latest version of Claude. Google has a frontier model, the last version of Gemini. And so these are the cutting edge models. They're competing against each other at the very highest level of performance. DeepSeek has an open source frontier model, which is something new and insane, that there's now a free open source model that's a frontier model that's competing with the big boys. So very cool, very interesting, very scary. Says things about, can we really control AI or not when we have a free open source version that's as good as the big ones? Anyway, if you have a large language model, are there small language models? And yes, there are. So a small language model is trained on a smaller data set, or it's distilled from a larger model. So you use the larger model to train a small one. Sometimes you train a small one that's general purpose, but small enough to fit, say, on a phone or in a laptop. Or you might want to distill a model that's specialized, that's just for medicine, or just for answering questions about how does a smartphone work, or whatever your small category is. So that's a small language model. They can be very, very useful, and if it's a narrow domain, it also can be highly accurate. So very cool thing to keep an eye out on if you're looking to run models on your phone or your laptop, or if you're a business and you're looking for a low-cost model that you can run on your own servers to do very specific, narrowly focused business tasks. You don't want the AI to write a poem, some poetry for your customers. You want the AI to explain how to use the product, and that's it, right? You don't want it to go into weird flights of fancy, and you don't want to be paying for that. You just want to pay for something that does what it's supposed to and is trained on a very specific stuff. To do that, you can use an open source model, and distill it to get a smaller one that does just what you want it to. So a very useful skill if you're in business. How does this differ from machine learning? So in common use, so technically all AI is machine learning, right? But in common use, when somebody talks about machine learning, they talk about AI from like 3 years ago or 4 years ago or 5 years ago. This is where Netflix predicts what you're going to watch next. This is where Amazon predicts what product you might want to buy. This is where Google predicts what the most useful website's going to be for you. This is where Boeing predicts when an engine is likely to need repairs. So this, or it's used to predict if something is malware or a virus or not, or is this a safe download? Is this spam or not? That's machine learning. So machine learning looks for patterns. It clusters things together that are similar. So these types of people are usually buying baby products, and these types of people are buying motorcycle parts. So it does that kind of clustering. It does predictions, clustering, and anomaly detection. So this is weird. This is unusual. This is probably a virus. So those are the kinds of machine learning tasks that machine learning models would do. And machine learning is very difficult. It requires data scientists. It requires very large data sets, very clean data sets. It requires a lot of tuning of these models. And this is not something a person would use on their own. You might use it like as part of the Google search or as part of using Netflix, but you would not yourself be running a machine learning model at home unless you yourself are a data scientist or a statistician or a mathematician, and it involves a lot of high-level mathematics. So you really have to understand statistics and analytics and those kinds of things to be able to create machine learning applications. Generative AI applications are trained differently. They are trained on unstructured data, and they decide what patterns to look for. So in machine learning, you tell it to look what patterns to look for. What kind of people buy these things, right? Whereas in generative AI, it kind of comes up with the patterns on its own. And like I said, patterns behind the patterns and patterns behind the patterns behind the patterns. So generative AI is much more advanced than machine learning, but machine learning can be much more accurate, faster, and cheaper. Generative AI requires less expertise to deploy. You can download a generative AI tool from an open source repository, maybe a small language model or one of these lightweight ones, and you can run it on a consumer grade computer. And if you have some graphics chips in there, you can actually run a bigger model on there. You can fine tune models yourself without being a data scientist or a data engineer or a mathematician. And there's instructions for how to do it, and you can follow those instructions, and you can create your own fine-tuned model. So for example, a lot of artists and photographers who are trying to adopt AI as part of their workflow are fine-tuning these models based on their own previous works of art. For example, if you're using AI to do voiceovers, you can fine-tune it on your own voice. And there's now commercial tools that just do it for you automatically too, so you don't even have to mess with it. If you're in a company, you can just include an API call to OpenAI or Anthropic, and they give you all the instructions for how to do it, and the AI can actually write the code for you. So it takes a lot less expertise to get started in it. The barriers to entry into AI have never been lower, and the AI systems have never been this powerful. So it is very exciting what's happening out there, and I'm hoping that you've got a little bit of more understanding than maybe when you started with, or maybe you have less understanding because I've confused you. Let me know in the comments below. So Subscribe to this channel if you care about it. And if not, that's okay too. All right. I'll see you guys next time. Bye-bye.